start a brand new chapter, as promised you guys. It's chapter 8, it's quadrilaterals, okay? So, quadrilateral means what? James? Generally speaking, yes, a four-sided figure, correct. So we're going to be studying a couple of the shapes. We're going to be studying a parallelogram, a square, a rectangle, and a rhombus. Now, it used to be that we would teach you guys a kite, and we would teach you guys a trapezoid. You guys familiar with those? However, that was taken out for this new curriculum that we're teaching. So we're just going to teach you these four shapes and the properties and fundamentals about them, okay? So our first shape I'm going to introduce to you guys for a topic is parallelogram, okay? And so what we're going to do is we're going to fill out this KWL chart. Have you guys done one of these before in your classes?
Yes.
Yeah. So just in case if you're not familiar with this, the K stands for what you know already. The W is what you want to know, and hopefully you guys are all curious. And L, hopefully we can take all the wants to learn, all those questions, and turn them into something that you've learned. Okay? So one at a time, maybe raise your hand. What's something that you know about a parallelogram? William?
I know that to find the area of a parallelogram, you have to multiply the base by the height.
That's correct. So area is equal to base times height. That's a good fact.
Yeah, it has 4 sides.
4 sides, good.
Quadrilateral.
4 sides. Good, I'll write that down. Quadrilateral. Oops. Not be lazy. Quadrilateral, Imani? All sides are equal. Is that an always statement?
No.
Okay, so sometimes that can happen, right? Okay, so maybe that's something we can put over here when we get to that point, okay? Here?
There are 2 sets of sides that are parallel.
2 sets that are parallel, very good. So how about we say 2 sets of parallel sides? Is that good? Okay, very good. Maybe somebody over here? Anybody? Okay, anybody else have any other facts over here? Colt?
I don't know for sure, but are there diagonals perpendicular?
We'll talk about that. Not necessarily in a parallelogram. Okay? Let me ask this. Anybody want to volunteer to draw me what a parallelogram is? Come here, Riley. Does anyone know what the shape of a parallelogram looks like? Okay, so let's actually get that down. That's something that we all know. Yeah. Yeah. Perfect. That's it. Everyone familiar with the shape? Okay, excellent. Good job, Riley. Okay, Justin, what do you know?
Don't the angles out of the 360?
Good. That's excellent. Yes. Angles, I'm running out of room here, but angles equal 360, and more specifically, let's say the interior angles, okay? Okay? I think that's a lot of facts about parallelograms. I'm not sure when actually this is introduced in school. I'm assuming maybe an elementary school topic? Maybe middle school? I don't know. All right, what do you want to know? This is usually where I hear crickets, but what do you guys got for me? What do you want to know? William?
What mathematician developed the form of a parallelogram?
Okay, we can look that up.
We can look it up.
Okay, what mathematician, let's see, founded I'm just going to abbreviate there, founded a parallelogram. Well, that's a question, isn't it? Okay. I liked Amani's question in particular. She said, you know, do all the sides have to be congruent? So I think that's something that we're going to explore. Do all the sides have the same measure? And what do you guys think about that? Just talking out loud. What do you think? Do you think that for all these sides have the same measure? Sometimes, okay? Sometimes. And if it's sometimes, what does that mean? Okay, so do the parallel sides have the same measure? That's good. Parallel sides have the same measure. That's a great question. We're going to explore that one today. Okay, Avery?
Would the opposite angles have the same measure for parallel lines?
Very good. Okay, so what about these opposite angles here? Okay, so opposite interior angles, or what do we know that as? Alternate interior angles. I wonder if that has anything to do with parallelogram. Okay? Get where I'm going with that? Question mark. And I think that's plenty for right now. Just for the sake, I ran out of room here. Okay? So our goal, hopefully, maybe not the mathematician, we can maybe get that one at the end of the lesson. But definitely these facts about the mathematics behind the shape, we're going to explore today, alright? So, what we're going to do now is we're going to go ahead and make our foldable. We're going to actually create this into a parallelogram. Okay? So, let's go ahead and do that. This is a very easy foldable to do, okay? So, what I want you to do first is, I have my paper, I always have to think about this, landscape, right? Okay, I want you to fold it in half hamburger though. So fold it in half. Is that good? Now I want you to take your paper while it's still folded and just fold it over again. So just take it, I'm going to take the folded, the crease side, and bring it to the right. Just fold it in half again. So now it looks kind of skinny. Okay, and once you've done that, the folding part is done, just go ahead and open it all the way up. So if you've done it right, it should look like you've got, it's kind of hard to see with the yellow here, but you should have 4 columns. 1, 2, 3, 4. Okay? Now this is probably the most challenging part of the lesson. You'll need some kind of straight edge, so maybe the edge of your notebook, or ruler if you have one available. Okay, let me show you what you're going to do. Okay. On the farthest left-hand side, this column right here, you are going to draw a straight line from this corner down here up to this corner up here. Okay, it may help you if you just want to watch me first and then kind of, monkey see, monkey do. So here we go. I'm going to go from this corner up to here and draw a straight line. Like so. Can you see that up there? Yeah. Okay. I've got a few rulers up here. Anyone need one? Well, I only have so many, but how about I just put one on this side, you guys can share it. You guys can share this one in the middle. You can pass that back on. You girls can share this one, and I'll just put this one over here, so, okay? Just share them. And can you imagine what you're going to do now on the other side? The same thing. Okay, so once you draw that line in, you're going to do the same thing, except you're going to use the last rectangle here, this last column. And you're going to go from corner to corner again. Okay. Now I do want to illustrate something to you. Now it's all done. You're done with all the scissors and stuff. Did everyone go the correct way? 2 diagonals like this? Well, you're done with the paper part, that is. Now what I want you to do is, we're going to do cutting, but before we do that, observe. This right here is a what? Just the paper alone is what shape? And now what have you just turned it into? So the question is a rectangle a parallelogram? So let's see, here's a rectangle, right? Parallelogram, right? Parallelogram. So all a parallelogram is, I guess in everyday terms, it's a slanted rectangle, correct? But now the mathematics behind it, we'll be studying that. But just generally speaking, into everyday, as if you're talking to your grandma, I don't think she's going to care about the interior angles and the consecutive, angles and the sides and things of that nature. All it is in retrospect is a slanted rectangle. Okay? So now what you're going to do is you're going to take your scissors and cut those 2 lines so that you essentially have a parallelogram. once you're done with that, I'm gonna come around and collect the scissors. Anyone ready to turn in their scissors? I have a pair of scissors if anyone needs one. Who needs a pair of scissors? Anyone confused on what they're doing? Thank you. Mhm. Any scissors over here? Anyone need some scissors? Okay. And now the scraps, you can just hold off to the side. We're not gonna really use them. However, you do have some right triangles, right?
Yes, we do.
I think we're done with right triangles, right?
Yeah.
Yes, thank God.
You can just hold them off to the side, yeah. We're not gonna need them for the lesson. Okay? Anyone done cutting? Looks like it. Alright, so, this is where my number 5 comes in, your sense of imagination. Now, this literally came out of thin air when I was planning yesterday during 4th period. So let me show you what we're gonna be doing, okay? All these shapes that we're gonna be talking about, the 4 shapes, rectangle, rhombus, parallelogram, square, they all have a lot of the same qualities and characteristics and properties and stuff, but some of them do not. So it's really quickly to get things confused. Meaning, okay, hey, if the diagonals bisect this shape right here, do they bisect a rectangle? Do they bisect a square? No, that one only works for that one, and that one only works for that. So it can get really confusing. So I'm going to try to do some association with something that you may be familiar with. Okay, so welcome to the quadrilateral shore, okay, a spin off the Jersey Shore. And our first topic for today is going to be DJ Peter parallelogram. You guys love my blowout?
That's awesome.
Isn't that awesome? So every time you think of a parallelogram, hopefully you'll have this image of maybe Pauly D, or maybe I'm actually going to have you guys create your own blowouts when we're done with the lesson for your parallelogram. And what we're going to do is in your notebooks we'll have all the cast in a folder. So you can believe that tomorrow or on Monday we will be doing a Snooki. And I've already got this big old bump ready to go. Okay, so it's going to be pretty awesome. So what we're going to do is, this is kind of what I want you to replicate for when I actually have you make the character. So we're going to actually be writing kind of down here, okay? So leave some room. If you want to put a pair of shades on there, you definitely want to blow out of some sorts. This gel slick hair right here. It's real nice here. Okay? But you want to leave some room to write, because what we're going to do now is we're going to actually talk about the properties of a parallelogram. Okay? You all good with that? Okay. So let's move our guy over here, because he is the main star of the day. And you love it. I know you do.
That's clever.
I don't know how, I mean, literally, as soon as I thought about it, I was like, wow, I really got things cracked up in the head. But, you know, as long as it works for you guys, does it really matter? But,
No.
okay. Alright, so the notebook will come later. The notebook we're actually going to use for some examples. But for right now, we're going to go ahead and talk about what are some properties of parallelograms. Okay? So, I guess I'll start it here. Properties. Zoom in here a little bit. Of parallelograms. Now we could go over the top and make it like the personality of your parallelogram, right? This has all the personality traits of our newfound friend over here. But, all right, here we go. So one property that you guys need to know, what's one thing that you think that comes to your guys' mind? Two sets of diagonal sides, what about them? Oh, you're just saying it has them.
They're parallel.
Okay, they're parallel, good. So we want to write that the two sides, two sets of sides are parallel. So we should probably indicate that on our chart, on our little diagram here. So do the best you can. I mean, I know you'll run off here, but maybe just make, this is just indicating that we have parallel. We could probably even tape something to show parallel here. You see what I'm doing here?
Yes.
I'm just indicating that it is parallel. Okay. Now, the opposite sides of a parallelogram in here, they are congruent. Because now I want you to think about it. A regular everyday rectangle, what's true about the top and the base? They're congruent. And the same thing with the sides, right? Well, now if we're thinking in terms of a rectangle, isn't a parallelogram just a slanted one? Same rules kind of still apply. So we're going to write that the opposite sides are congruent. Okay. Also, opposite angles are, what do you think? Opposite angles. They are congruent. Very good. We're going to practice these in a little bit. Okay? Now let's still think about our parallel rules here. I want you to go back to when we did the transversals and stuff like that. What about, for example, these two angles here? What about right here and right here? Consecutive interior. And what did the rule say about consecutive interior? Add up to 180. Good. So the word that we use in geometry for add to 180 is
Supplementary.
Good. It's like music to my ears right there. So same thing. Consecutive angles of a parallelogram are supplementary. Now let's go back and think still in terms of transversals and from when we did chapter 3. If you had one right angle, what did that mean about the right angle down here? Well, I just gave it away. I didn't mean to say that. I meant to say what did it mean about the angle down here, but what is that? It's got to be right because 90 plus another 90 equals 180 for consecutive. Okay, so that means that this one over here has got to be 90, and this one down here 90. So if you have one right angle, all the other angles are also right, okay? Cool?
So a parallelogram can it have 90-degree angles?
Yes.
Or would it just be a rectangle?
Okay,
Or
well,
is
that's a
the
good question.
Okay.
So that's going to be a good maybe quiz for you guys, maybe an always, sometimes never quiz. Are all rectangle squares, or all parallelograms rectangles, et cetera, et cetera. I think that would be a good one for you guys. Thank you, Cole.
Okay.
Oh, I love kids like that. All right, so here we go.
Sometime you've gotten
If a
Part of the
parallelogram
script.
has one right angle, then it has 4. Does that make sense? I'm writing that? Okay. Okay. 6. Now there's something to be said about the diagonals of a parallelogram. Okay. Anyone have a clue what they think what had happened in a if you had two diagonals that came in, what do you think that means about each little path, in a sense, William?
They create 4 congruent triangles.
Not necessarily. not necessarily, not always. That would happen if you had a rectangle, if you had all 90, okay? Yes? No, not perpendicular. I'll just go ahead and give it to you guys. It's the diagonals of a parallelogram, they bisect each other. So if they bisect each other, what does that mean about each half? They're equal, right. And we'll see that with a few examples in a few. But the diagonals bisect each other. Okay, and the last thing sort of goes off of what William was saying about the triangles, but each diagonal, and this is the last rule, so if you're wondering you're running out of room, this is the last one. Each diagonal separates a parallelogram, I'm just going to abbreviate it with the symbol there, parallelogram into two congruent triangles. Okay, and you better believe that in this chapter, we will be exploring the proofs of a lot of these theorems, okay, because that could be potentially be on your EOC or your Common Core exam, okay? Questions about any of these properties here? You pretty comfortable with this? I think a lot of it, if you think about it in terms of a rectangle, I think it will make sense to you. Because I'm trying to get it across to you that a parallelogram is just a slanted rectangle, okay? So let's go ahead and put that off to the side and take out your notebook now. And let's do some examples that illustrate these properties.